Alright guys, here we go. First video of 2017. Now I've heard from many of y'all that my voice can be quite boring in class. I'll try my best to not do that on the video as well, since y'all get enough of that in class. This will be a work in progress. Hopefully these videos get better as we go along, but hopefully this stuff helps you and we'll see a rise in our test scores. Alright, so let's get started. This is the first slides that we have covered the past week and a half. So lesson 1, linear relationships. And by the way, this will be uploaded in 15-minute segments, so I recommend that you watch all of the parts. For some of the stuff, this may be easy though, so it might work out that it's in segments. That way you don't have to watch the whole thing. You can just find the part that has the lesson that you didn't quite understand, and you can just watch that little segment. And then you can get back to your Snapchat and Facebook. Alright, so a definition of a linear relationship. A relationship between two quantities that have a constant rate of change in a straight line graph is called a linear relationship. So this first part will help you figure out if a table is a linear relationship. The second part, this underlined part, a straight line graph, is another way you can tell if it's a linear relationship, and that's if it's on a graph. And this is fairly simple. So let's look at through a table. So we've got two tables here. So like a question it might give you on your test is, it'll ask you whether or not these are linear relationships. Well, let's look at this one first. So how you go about solving this is you have to look at your column of x's. Oops. Told you, work in progress. You got to go about looking at your x's and then your y's. We're looking at how much they're changing as you go from one row to the next. So like this is an ordered pair. This is a row. Okay? This is a row. So as we go from one x to the next, we see that it's plus 2. From 4 to 6, plus 2. From 6 to 8, plus 2. Okay? So since these are all plus 2, we can tell that our x's are changing by a constant amount. Now let's look at our y's. So we look at all of our y's. So going from 50 to 35, minus 15. 35 to 20, minus 15. 20 to 5, minus 15. So all of our y's are constant as well. So all of our x's are constant, all of our y's are constant. So we would say that this is yes, it is in a linear relationship. Same thing with this table over here. Okay? So it starts off good. We see that all of our x's are constantly changing by 3, plus 3. And the signs are important, because we will have to do this when we find our slope in one of the later lessons. So make sure you remember this, the sign that it's changing by. Then we look at our y's. We see that they're changing by not the constant amount. Plus 15, plus 33, plus 51. Those are not constant in our y's. So we would say that is not linear, a non-linear relationship. Linear, not linear. Okay, so here's some more practice problems for tables. So we see here that, look at our x's. We see they're going by plus 5, 0, 5, 10, 15. Now we got to check our y's. We see that they are going down by 4. 20 to 16 is 4, 16 to 12 is 4, 12 to 8 is 4. So our x's are constant and our y's are constant, so therefore it is a linear relationship. Let's look at B. Our x's are all going up by 2. Our y's are all going up by not the same amount, because 0 to 2 is 2. 2 to 8 is 6. 8 to 18 is 10. So that is not linear because our y's are not constantly changing by the same amount. Okay, and this is really easy. This is how to tell if it's a linear relationship by looking at a graph. So a relationship between two quantities that have a constant rate of change in a straight line graph is called a linear relationship. So that's just a review of the definition. So looking at the graph of this table right here, because you can graph tables, and this word problem over here, this is can't think of the word right now that I'm looking for, but we can graph it. It's like a situation that we can graph. Okay, so looking at this graph right here, we can see that it is not straight. It has a series of straight connected lines, but it is not one straight line. So therefore it is not linear. But we wouldn't even have to look at the graph because we have a table right here. So you could also do it from the form of a table. So there's multiple ways you can look at this. And this is the same throughout this whole unit. There's always multiple ways to figure out these problems. You just have to find which one's easiest for you. All right, next slide. And this is just another example problem. So the last one was not linear, but this one is linear because we can just look at its graph and we see that it is one straight line. One straight line. So this one is indeed linear. And you can also make the table from the graph to double check your answer. And these are just more example problems. You're free to pause the recording and work these out. They're fairly simple, so I'll go ahead and continue. And yet more problems. So you can get plenty of practice by working these. All right, on to the next lesson. And please, if I'm going too slow, too fast, my tone is boring, or anything of that nature, please let me know in class, and I will try to address those in my next videos. I'm always open to feedback, so don't ever think I'll be mad if you have constructive criticism to offer me. Okay, so now we're going to find slope. Slope is that constant rate of change between any 2 points on the line, and it's known as slope. Okay? So these are points right here. These are all points. Okay? They each have an x coordinate and a y coordinate. That is very important to know that everything we're working with right now relates to x and y coordinates on a graph. That's for all the lessons from this unit. So like just for this one right here, you could say that is about, it intersects the x-axis at 4 and the y-axis at about, I don't know, 75. So you would write that one as 4, 75. Okay? So next slide. So slope equals constant rate of change. That's the meaning of slope. And then this part right here is how you find it. This is the formula for slope. There's two different ways to think about it. You will use change in y over change in x for tables and for equations. And you can rise over run whenever you're looking at a graph. And I'll explain that further on the next slide. So between 2 points. So they will give you 2 ordered pairs. Okay, so 2 points on a graph. So, and you use those 2 points and you plug them into the slope formula. This is the slope formula. So you're going to do the second y coordinate minus the y coordinate, so here and here, divided by the second x coordinate minus the first x coordinate, okay? So in this example right here, it says find the slope between the 2 points. Then it gives you 2, 12 and 4, 6. So you could, the first thing you always do in these types of problems is label the y's and x's for your formula. Okay? So, and excuse my sorry handwriting, I'm going to have to find some kind of pen that I can use to draw on these. Right now I'm just using my finger, but hopefully this won't be too bad. So you can do this as x1, this as x2, and then this can be your first y coordinate, and then this one can be your second y coordinate, okay? So, according to this formula right here, I'm going to plug in my numbers, and it'll look my coordinates, and it'll look like this. So y2 is 6 minus y1 is 12 divided by x2 minus x1, so that's 4 minus 2. Now I just do my math and simplify, because we always want to simplify our fractions. 6 minus 12 is negative 6, and 4 minus 2 is just 2. So our slope is negative 6 over 2, but we want to simplify or reduce that. So I'm just going to do the numerator divided by the denominator, and I'm going to do negative 6 divided by 2 equals negative 3. So our slope for this example right here is negative 3. And all I did was use this formula and plug in my points. Simple as that. Alright, so next slide. So this is just revisiting how you identify the tables. If it's linear or not through the tables. And then this is practice. So if you want to pause this video and do these problems right here, that would be a good idea, just to get some extra practice. So every time I click on the screen, it's going to show the answer. So I would pause the video as soon as the problem comes up, and then a few seconds later I will show the answer, so you can check your work with the answer. And then this is more practice. Okay, so now we're going to try to find it when given a graph. When given a graph, we use the m equals rise over run formula. The student should know what m is equal to by now. At the time we went over this slide, you didn't know, but we have gone past this slide already. M is just the slope in our slope-intercept form of an equation. So remember, the slope-intercept form is y equals mx plus b. So m is our slope. So anytime you find slope, it goes before the x in our equation. So whenever you have a graph, this is how you do it. You always find your rise first, and then divide it by your run. So rise over run. So you need to pick two coordinates that are pretty. So when I say pretty, what that means is that it intersects an X and a Y, and it's nice and even. You don't want a point, so like right here, this point right here, it intersects an X nicely, but it does not intersect a Y nicely. Sometimes you might have whole numbers going on these lines right here, and you'd have to give it like a 0.5 or 0.6, and that's hard to tell by looking at it. So it's always easier to just pick nice, easy ones. So I would say this point right here and this point right here are nice and pretty. Right there. Okay. So now let's find our rise divided by our run. So my rise looks like I go up 2 lines. So I'm going to write a 2 next to that. And then my run, or my horizontal change, so yeah, I forgot to mention that. Rise is vertical change, run is horizontal change. So I'm going to calculate my horizontal change by just counting the lines. So 1, 2, 3, 4. And it's not very pretty, but again, this is my first run, so bear with me. So 1, 2, 3, 4. So if I'm going to write this in the form of the formula, I would say M equals my rise, so 2, divided by my run, which is 4. And then after I reduce that, it comes out to be 1 over 2. So my slope is 1 over 2. And I do have to say this is the easiest way for my kids so far to learn this. If I say my kids, that's if any adults are watching this. Hopefully y'all do, because that would help y'all to help teach your kids as well. So let's go to the next slide. And this is just an example problem. So they graphed this table right here. They just plugged in these points. So they got 0, 0 right here. Then they've got 1, 5 right here. And then each one of these points they've graphed. So on and so forth. So they decided to use these 2 points in order to find the slope. Again, it does not matter what 2 points you use. They don't have to be next to each other. They can be the farthest ones apart from each other. You could have this one and you could have this one and this one down here if you wanted to. It doesn't matter. Because guess what? That's part of a linear relationship. It has to be constant. So the slope, or the steepness, if you want to think about it in terms of like a hill or something like that, will be constant throughout. And that's why you can use any 2 points. So if you wanted to use a table, if you wanted to use this table right here, you could use the M equals y2 minus y1 over x2 minus x1. Or if you only had a graph, and I prefer the graph over the other one because you don't have to do all you have to do is counting. You don't have to do much math. Or if you just want to use the graph right here, you can just do rise divided by run. And it all boils down to change in y over change in x. That's all it is. That's what both formulas are telling us. The slope will always be change in y over change in x. It's just written in 2 different ways, but they basically say the same thing. So let's go to the next slide. Actually, I'm about 4 minutes over how long I should have gone. I'm going to try to make each part around 15 minutes so it doesn't take 5 hours to upload this stuff to the internet. So part 2 will be covering some more example problems, and we'll go on to the next lesson after that. All right, thanks.